So one thing we have to do when we do type checking is check that the types of arguments correspond to the types declared in a function, right? Or in an assignment statement, we want to make sure that the type on the left-hand side is the same as the type on the right-hand side. So we have this example here where x and y are declared to have type foo and type bar. And the question is this assignment legal, right? How do we check that foo and bar, are they equivalent in some way? So this question of type equivalence is something we need to have an understanding of. So there's a few different ways to think about type equivalence. A simple one is simply name equivalence, right? And so in this case, we simply check the name of the types. And so in name equivalence, right, here we'd see that, okay, foo is not the same name as bar, and so thus those are different types. Right? So this is what happens in, for instance, Java. We have two classes. If they have a different name, then we don't see them as the same type. There is a subclassing concern we have, and so that's the one case in where these the names are not considered. But when we get to talking about structural equivalence, we'll refer back to this point about name equivalence being something rather different and what's happening to some extent in parts of Java. Another one here, anonymous types, right? So these don't have a name. So here we have a couple declarations for x and y. They are arrays. They are the same type. They look like the same type. However, they don't have names, and thus name equivalence as a scheme would specify that they are not the same type. This is what happens in C with structures. Right? So structs in C that have the same structure are still treated as different things if they are anonymous structures. Right? They don't have a name, so we don't attempt to say that they are the same thing. So that's name equivalence. Transitive name equivalence. This is one where we are allowed to use type defs in C or the type keyword in Pascal and say that one type is the same as another type. So this is often done when we introduce new types, right? Right, so in a language like Pascal, we may say type length is equal to integer. And in our code, we'll say, okay, I have some variable x of type length. And if we have another variable y of type integer, then what if we do x set equal to y? Is this allowed? Right, well, under strict name equivalence, we would say no, because they have different names for their types. Under transitive name equivalence, we say yes, because we take these specific specifications of type equivalence and take these into account. Right? So there's something that tells us that type length is equal to type integer. Right? We've written that in the code, and thus we can transitively apply these equivalences to try and see if, for instance, length is the same as type of integer. All right. The third type is called structural equivalence, and structural equivalence is one where we don't concern ourselves with only the name, but we want to look at the structure of the data as well. All right, so here we take a few things into consideration. Right? So under this scheme, if the two types have the same name, then we consider them to be the same. Right? So two integers, of course, they have the same name, and they're the same type. If they're defined to be the same, so this would be our transitive name equivalence we just seen, then we also consider them to be the same. And then third, if these types are constructed by the same constructor, then we apply this process to their component parts to check the component parts. Right? So if we have two arrays, then we would say, okay, they may be structurally equivalent if their element types are the same. Right? So here's a couple structures. Right? So here we would say P1 equal to P2. This is allowed under structural equivalence because P1 and P2, their types, have exactly the same structure. So we call a strict interpretation of this as well. Let's then just apply this in a rigorous way, and we get what's called type expression equivalence. Right? So what we want to do is replace any names introduced by the programmer with their definition in these types, and keep replacing type names with their values, their type expressions, until we've unfolded all of these and can then check to see if these type expressions are in fact the same. Alright, so structural equivalence gives us a little more freedom. It's often useful, but we also have a few challenges in this scheme, and that's what we'll talk about in the next video.